Okay, well, hello. Yeah, all right. So this is, given this talk a couple of times, and people come in with different sorts of expectations. Again, only a half-hour talk, so the idea is to get you interested and enthused about what I'm talking about here. I can't really show you maps, imaginary maps, because there's a contradiction there. But what I want to sort of talk about is how could you do something like, like I'm going to show us a map of something that isn't real world, doesn't currently exist. Think sort of Google Maps, but over your own imaginary island or your own dungeon if you're doing role-playing games or something like this. I lost a lot of hours in my university years being a dungeon master, and I would have killed for this sort of thing back then. It would have been awesome. Quick audience participation moment. How many people have done anything with GIS, Geographical Information Systems? 3, 4, 5, 6, and I probably could have picked about 70% of those people before asking the question. Right, so for those of you who haven't, GIS is sort of the generic area, Geographical Information Systems, doing data queries that involve latitude, longitude, altitude, topographical things, queries involving regions. So think we have GIS databases, right? We have databases, instead of saying, does this string match this thing, it's does this polygon intersect with this other polygon, or find me all of the paths inside this region. So what I'm talking about here is the general area of GIS sort of stuff and how to play with it yourself. The sort of basis of what I'm doing, just because of my history, is I'm building a lot of this on top of Django, because Django comes with a whole bunch of GIS components built in. And if you've never used this before, that's fine. Again, let me use this as an introduction to get you enthused about what can be done. The sort of preliminary to this talk, at the end I'll show you all the slides and a whole bunch of code and a very long README, a couple of thousand words, is online at GitHub with how to set this sort of stuff up so you can play with it yourself. It's not quite a 10-minute job because there is a little bit of preliminary setting up, but after you've done the 20-minute setting up period, it's all downhill sledding from there. And I've been told, it's not polite to make your heads explode with complications, and whilst I'm not necessarily in favor of that policy, I'm a guest here, so I'll try and keep it reasonably simple and understandable and pretty pictures. So, out of the box, Django, for those who haven't used Django at all, one of the strengths of it is meant to be it comes with this nice administration interface. So you build up your database tables and models, and it has a very nice out-of-the-box web interface for viewing what's in the tables. Way back 2007 or so, a guy who was meant to be studying law in Texas, in his free time, decided we need more GIS support in Django, because a law degree isn't very demanding. So he thought in his hobby between studying for exams and things like this, he'd build in mapping support to Django. A guy called Justin Brond, very, very clever guy. He's now running a startup where he's both the chief technologist and the lawyer. They're saving a lot of money. And so the clever way to do this is of course use what other people have built beforehand. And what's been sort of around in the industry for a while are things like OpenStreetMaps, which is a community sort of crowdsourced mapping situation of people go out with their GPS systems and plot roads and enter the names into a database and so on. And one of the things we need if we're going to have all this data collected is a nice way to display it. And it's really, really fiddly to display maps. So they came up with a number of JavaScript frameworks for displaying maps on screens, one of which is called OpenLayers, which is a very nice JavaScript sort of framework for doing this kind of thing. You give it the backing thing. So on this screen here, all of the names and the fields here is Django standard admin interface, like the Chrome here is standard Django. The map is obviously something special is going on here. This is OpenLayers displaying, as the JavaScript layer, displaying some data from the background, and the GeoDjango app serving up that data. This happens to be a map of southwest Tasmania in Australia, showing a catchment area for some river. All of the little fiddly bits on here, they zoom in and out and navigate around, and apparently these are for drawing things on the map. I mean, without even playing with it, you can see, okay, they must be for drawing polygons or lines or something. That's all OpenLayers. It kind of gives you this information for free. And so that's all very nice, and again, I won't go too much into that beyond saying that in Django itself, back over here, this is a portion of the documentation for Django just focusing on the GIS stuff. Now, I said I was trying to get you enthused about this and not make your head explode. You don't have to understand all of this before entering the water. There is a lot of stuff here for doing very, very professional level stuff. The point being that it does start out with a very nice entry-level tutorial, a lot of installation instructions because it can be fiddly, but it's written by nice people who like you and want you to succeed. So it's actually a matter of usually just following the instructions. And there is, as you go into it, there is a lot of documentation for doing stuff at various levels. But I haven't read it all. I don't think well, I probably have at some point to proofread it. But you don't need to memorize all this, is the point. You can actually be doing useful stuff at the point you get down to about here, sort of 3 chapters in. Now, and out of the box, like the tutorial here teaches you to import world boundaries. There's a very nice data file floating around, which is all the boundaries of world countries, how to import it into models, display it in the admin interface, and end up with something like what I had on this slide back here. This I happen to import a map of Australia and a whole bunch of what are called shape files. Shape files are, as the name suggests, a file of all the shapes that you might want to put on your map, be they polygons or lines or points. We essentially have in GIS land, we basically have points, lines, and polygons. Points of just being locations. And so that gets you to here, which is fine, providing you're mapping real-world situations, which for 99.8% of people is what they want to do. Maps are useful when you want to go somewhere. I am in the other 0.2% of people, don't really like the real world, but wanted to see what could I do with what I've got here, right? What if I want to replace the map of Australia or the map of the world or something with something else?
Middle Earth.
For example, yes. At that point, the next step, you go, I could do that. That would be cool if I could work that out. And then you realize, I can't really draw very well. But we'll cross that hurdle when we come to it. So, yeah, these were the kind of questions I went, all right, I've done the tutorial. That's cool. It was a part of Django I didn't write, and it just sort of worked, which was nice and encouraging. Gee, I really should have done the slides in the order I was talking about this. the JavaScript, like I said, the sort of open layers is a big, we've got a sort of stack problem here. We've got everything from data in a database, and if we're talking about lines, polygons, points, we need a way to sort of store that in a database because it's not your average text and integers and so on. And we've then got how to serve this up to a web browser or to a desktop application or something like that. And we've got, if we're doing to a web browser, how do we display that in the web browser? And how do we let people navigate around, because we don't all want the same view of the world. We sometimes want to zoom into actually where we live, and we're spread all across the region. So I need to talk a little bit about the stack of tools here from database all the way up to the top. Open layers, let's start at the top. Open layers is the JavaScript layer running in the browser that, like I showed you on that admin screen, provides us with the ability to navigate around, to zoom in, and so on. It doesn't actually do the navigating and the zooming, but it constructs the right queries to pass back to the web server on the back end so that the web server can send you the right data. Because, I mean, think about it. Everyone's used Google Maps, for example, or whatever Microsoft's equivalent of that is, or OpenStreetMap, or things like this. You're there, you've got a particular region on the map, and you typically want to zoom in, or you want to translate to somewhere else. And what you're really doing, you're telling your web browser, okay, please zoom in. It sends a request back to the server, which sends you back a different image to display on the screen, which is the zoomed in view, or the slightly moved view, or something like that. So clearly, something on the back end is happily got all these images that it's serving up to you, and we'll get to in a minute how those images, where they come from. But there's the bit on the front end that is telling it, I need this kind of this region to show me this rectangle of the world. So Open Layers handles that user interface portion. The last point here is, again, expectation settings. It's very easy to get up and running with Open Layers. In 3 years or so, I have not yet stopped learning new things I can do with it and how to tweak it, and it's a fairly fun time suck. You sort of sit down going, I really just want to change this, and why is it dark outside and I'm really hungry now? Because you kind of get sucked into doing things. Because it's used for OpenStreetMap, it is very well maintained in the sense of being reasonably backwards compatible, lots of powerful features, a very welcoming community. It is, in that sort of sense, it's a good project to play with as a user because it is both used by enthusiasts and professionals alike, which is always really the best crossover. Next layer down, after we've got, okay, web server sends something back to web browser sends something back to the web server, I would like to see this region that includes my home or includes my country or includes where I'm going to travel. There are a few different layers here. The one I'm talking about is called Mapnik, which is a server, again, used by OpenStreetMap, used by a couple of other things. Mapnik itself is written in C++, but it has a very good set of Python bindings that maintained by more or less the same people, so they tend to track each other very nicely. It's recently undergone a fairly major, not rewrite, improvement set. It was stalled at Mapnik 0.7, a few of us suspected forever, but it turned out they were working busily in the background, and they've recently released Mapnik 2.0. 1.0 would have been too passé. They've gone straight to 2.0 at this point. And are about to release Mapnik 2.1 very shortly. So they've clearly got their blood up for doing new releases. They've worked out how to do it now and full steam ahead. And again, to their credit, it's pretty backwards compatible with 0.7. I mean, the code I'm talking about here, I originally wrote portions of it 2 or 3 years ago. About 3 years ago, I think the first set. Most of it just worked. When I ran it against something 3 years later, I had to make sort of one import change in the Python level, and then it all just worked. So Mapnik's a pretty good set of server. And what it does is it combines a map, so something like, well, let me show you a real example. Here's one I prepared earlier. Here, as the title suggests, is an island that doesn't really exist. Which is also good because it doesn't seem to have any facilities like airports or landing things, but I can't draw very well. So what a standard map like this, what does it contain? There's again, the open layer sort of Chrome, if you like, the ability to move in and out and navigate around. We've got what's called the base layer, the image underneath, so the ocean and the sort of topographical representation underneath here is called the base layer. It's the thing everything sits on, and it could just be, a blue screen or a green screen, or it could be a map of the world or a hand-drawn map of your dungeon or what have you. I spent a fair bit of time screwing around in the GIMP and Inkscape and QGIS to create something looking like an actual island. There's some links in the README about where I went. There's a nice web forum called thecartographersguild.com that has a huge section of tutorials on how to create really nice looking maps, even for dummies like me. So I followed their tutorials. And then on top of that, we have things like, well, you can see here, there's a few different paths laid out, and there's a few points of interest floating around here. I seem to remember the sort of backstory was some guy getting shipwrecked on an island, and we found his diary and plotted the paths he wandered around and where the ship got wrecked and stuff like that. And so I can turn on and off here, this little button over here that isn't very clearly labeled. Whoops. I can turn off, for example, the tracks. So we see the base layer, which is my imaginary world. On top of that is a layer that is the tracks, and a different layer that is the notable points. So again, this is not unfamiliar with professional mapping level things we know about on the internet, where you can turn off street names or restaurants or what have you, traffic patterns or things like that. So something like Mapnik serves up a base layer and then various layers on top of that he gets data. So it's a way to combine data from various sources. It also understands the concept of zoom levels. So in my case before, I'm showing you pretty much my whole world. It's a little 10-kilometer square world. The actual world is bigger, but my one's only that big because it takes a while to create content. But Mapnik understands I can zoom in on that map. Again, if I go over to here, I have to be very, very careful here, because if I zoom out all the way, it goes horribly badly. But it understands, hey, look, I've zoomed in, serve me a slightly different view of things. Now, in my example, I'm just using the same base image that gets scaled up by Mapnik, but I could tell it, when you zoom into this level, start using these images over here, because they're actually of higher resolution. When you zoom in really, really closely, do my equivalent of Street View. Show me, a real close-up of the monster's teeth or something like that. Possibilities are pretty endless there. It just comes down to creating the backing tiles, if you like. Like this is the base map, think of it is a tile. I only happen to have one tile, but I could have, if my world was a lot bigger, I could have many different tiles. You see this on, again, I hate hate to keep sort of plugging one product, but Google Maps is something everyone's used. As you scroll around Google Maps on a slow connection, you sort of see the tiles kind of paging into the display as they go and fetch different images. And that's exactly the type of thing that Mapnik allows you to do. And raster and vector formats becomes important. So raster formats here is, think pixels, right? Line by line, pixel by pixel display. Vector format is displays of points with lines between them. Vector formats have the advantage of scaling really nicely. I can scale infinitely up because I can always say, here are my 2 points, and just draw the most accurate line you can between them. Raster images do not scale quite so nicely, but they're sometimes easy to work with. Mapnik can handle both formats. So the base layer in my case is a nice raster image. The paths and the points and the polygons are all vector formats. All of this is not free in the sense that as I'm scaling in or perhaps displaying paths or points or things like this, it can take some computing power. So there tends to be another point in the stack, which is the caching layer, which says, okay, lots of people seem to be requesting a view of Singapore today, or a view of Singapore zoomed in here, or something like that. Or possibly, as in the what I know how OpenStreetMap work here is, they generate all of their tiles and all of their resolutions for their maps every 3 days or something. I think it's every 3 days. It might be faster now. It was 3 days a year or so ago, based on their computing power. And they just run through and they generate basically all these views and put them in a cache. And these caches tend to know about tiles. Again, they're not just web page caches, they know about geometric regions, rectangular regions. There's one called mod tile that tends to, you might believe from the name, works with Apache. Mod underscore anything tends to be an Apache thing. Tile stash is a more or less Python only tiling cache that someone wrote more or less for fun. That's good to play with. There are other ones around, but they're the two I've sort of played with. Tile cache sort of works, tile stash, sorry, works fairly well for my purposes. Around the same level as something like Mapnik is something like GeoDjango, which says, okay, so Mapnik is providing me with a way of turning the data into images, combining data from various sources. I have to give it the sources. Mapnik knows about my base image, for example, but I need to tell it, okay, these lines are of interest in this particular view. If we go back to the example over here, as I zoom in more and more, so if we pay attention to some of these tracks that are on the lower part of the screen here, as I zoom in a bit more, the parts of the track over here, or the dots, the notable points that have dropped off over the side there, are no longer of interest when I'm computing this image. It's very wasteful to recompute all that data. And this is something where in the background, Django is getting a query saying, I need all of the points that are inside this box, whatever the dimensions are. You can imagine there's sort of information going to the back end describing somehow the view region here. And it's being told, give me everything that would appear inside that box. And we'll see in a minute what the sort of code for that looks like. But again, it's basically a database query. Once you get your head around the fact that we can do this sort of SQL-like queries that intersect polygons and lines and points rather than just strings and integers and dates. So effectively this is saying, I have a box, find me everything that intersects that box from my paths table, which is what I happen to call, or tracks or something, I think I called these lines, and also from my notable points table, which are the dots floating around here. Find all the notable points that are inside this region. And that's just a database query. In the background, I'm really hoping the next slide is the database. Okay, kind of includes it. The very bottom layer here is a database that knows about GIS stuff. Now, PostGIS is a GIS layer on top of Postgres. Again, naming is not very subtle. There's a thing called Spatial Light, which is a GIS layer on top of SQLite. There is one for MySQL. There's the GIS one. The MySQL one kind of sucks, so don't use that. Use the PostGIS one or the Spatial Light one. Oracle has its own GIS layer. All of these GIS things, they introduce new data types, typically polygons, lines, points. They introduce new query types, intersects, bounding box queries, like find me the bounding box of all of the elements, like do a select that pulls back a whole bunch of polygons and find me the bounding box of those. Or instead of just maximum and minimum and average, you now get aggregate queries like bounding box or extents. The nice thing was that going back, I mean, GIS is not a new field, even in the computation area, particularly the resource companies, the mineral companies and oil companies and petroleum companies have done a lot of driving of standards around this so that they actually care about where things are on a map. When you go and find a natural gas repository, you'd like to know how to get back to it later on. So they put a lot of effort into standardizing various things here, including, fortunately, the type of queries. Like there is a sort of GIS SQL extension that's pretty standardized. Everyone uses it. Not everyone implements it perfectly, MySQL, but it's pretty well done. There are optional bits that get left out. So at the bottom of all this, we have a database that in my case contains my tracks and my points and things like this. Mapnik queries this to get certain information out. Django queries this. There might be a caching layer in the middle to save a bit of work on Mapnik. There's the open layers, JavaScript in the web browser. So we've got here web browser, web server, both of these layers, well, some kind of server, web server, database layer. You're probably thinking, this is easy. I haven't shown you any code yet, but we'll get there. So if I'm going to do imaginary maps, I need to replace the base image because I no longer can use a world map that sort of you tend to get world maps for free. So I need to make my own base image. I need to tell the admin interface in Django, if we go way back to the start here, you know, this is using the standard world map, and it's all very well for me to pass it in certain polygons or something, but I need to have them also displayed over my version of the map. And I need to run a, you know, I need to serve that data up from somewhere. So in this case, what I'm doing is running a little web mapping server. The Mapnik comes with a little Python Whiskey web server built into it, and that I'll show you in a minute. That is literally in 4 lines of code. I am running the web server that is serving the. In this example, I have a little bit of Django running to serve the line intersection, and this open layers interface is querying a Mapnik server that is about 4 lines of code long. I mean, it's not, it's hundreds of lines of code, but the bit I had to write was about 4 lines of code, which meant it took about 3 days to work out the right 4 lines, but that's life in the software business. Right, code samples. Let me show you first so the queries do not look pleasant. I'll give you that. Debugging this can be a educational experience. You know, these are the sort of, this is the web mapping server. This is the queries going back to sort of Mapnik. It's not cool to debug. Firebug is your friend, Chrome Developer Tools are your friend, thing like that. But they didn't go out of their way to make these things very readable. But that being said, you know, the code that's involved here, is that hopefully readable from the back of the root? Make it a bit bigger. You know, there's not a lot going on here once we get down to the real nitty-gritty. I have to tell it where my configuration file is, create the little Whiskey app and run it. I mean, for development purposes, this is ideal once you get it up and running. And again, I put this code on GitHub so that you don't have to spend the 3 days of doing this. You can just copy and paste. And just to convince you, I'm not hiding the excitement in the configuration file. It's also not particularly difficult. And the other bit is, go back to, this is the type of configuration Mapnik takes to tell it about, you know, here is the data I want you to display. Here are the data sources I want you to display. The base layer is usually where most of the suffering is. The initial setup is initially to get it to display anything. You spend a lot of time staring at a white screen going, where is my map? I'm sure I put it in here somewhere. Because by default, Mapnik's sort of default view and open layers default view is the whole world. My island is 10 square kilometers. The world is bigger, 6,300 odd kilometers in radius, 38,000 kilometers circumference of the equator. So, you know, finding your particular patch of 10 square kilometers can take a little bit of doing. And I intentionally, I mean, from experience, having done this a few times, I intentionally now put my sort of imaginary lands at about 150 degrees or so, like not fully around the world from 0, but a long way around the world, so that if I get latitude and longitude the wrong way around, because if you remember, your latitude goes from 0 to 90 degrees and 0 to minus 90 degrees. Longitude goes from negative 180 to positive 180, or 180 east and west. By putting my longitude over at 150 degrees here, it means if I accidentally get latitude and longitude the wrong way around, it's really, really obvious, because things start complaining about latitude being too big. Similarly, I tend to put things on the equator latitude-wise, so that I don't have to go hunting for, where did I put it. It also happens to turn out that that particular location, 150 degrees longitude and 0 degrees latitude, there isn't anything in the real world there, so that if you accidentally get the world map overlaying it, it'll look very empty. These are all just sort of, when I screw up, I want it to be obvious. Nothing else there is particularly of interest, I'll just say. Back over here. In the Django side of things, I'm assuming a little bit here that people have done a little bit of Django work, or can at least sort of play along at home. A model in Django representing kind of a table. Things like character field is just very standard stuff, nothing GIS related here. The only sort of special GIS related thing here is this path field, and this is again a model of the tracks on the island. Line string field is the name we chose, perhaps unwisely, for lines. The string bit here is again a sort of nod to the standard. There's a few different ways to represent lines. This is a line that is made up of sort of stored as a string in the database. Geography equals true might look silly, pointless, tautological. It turns out to be a new feature in GIS things that says take into account the altitude of the path when you're doing intersections. Recent databases, post-GIS and things, have developed the ability to do intersections based on taking into account the altitude of the points as well. The models equals GeoManager thing is just a sort of artifact of the GIS thing. We need to tell it when you're doing queries, use the GIS operators as well as the normal SQL stuff. All right, that's more. For those familiar with Django, this is the type of changes I had to make it work in the admin layer. I basically just had to tell it, I have my own map server, go there, don't go running off to, I think it uses Google by default. Here's my name, here's my location. That took a while to work out. I'm not that good with maths. I wrote a little program to say I have a 10 square kilometer region of space that I want centered at 150 degrees longitude and on the equator. What's my maximum and minimum here? Worked out the bounding box. As you can see, it pays to be precise in these cases because 10 kilometers isn't very big. Is this? Yeah, okay. So a sort of request coming in from the open layers side of things is going to have parameters either bbox uppercase or bbox lowercase. Different JavaScript layers send uppercase or lowercase. They never seem to got around to standardizing that, so you have to do a little bit of hacking. Bounding box is literally a maximum and a minimum x and y coordinates. It's the upper left and lower right of a rectangle. And I turned that into a particular polygon type that GeoDjango knows about. Nothing special going on there. That's a sort of common thing for, I have a request coming in, give me the rectangle I care about. Whoops. Wow. Slide missing. Moment, please. Where is... Okay, so this type of thing, something like the tracks method here, is a sort of, this is the type of request we do for things. We get the box. This was the method I showed before. Give me the rectangle. Find everywhere in my model. I'm big on don't import too deeply. So adventure.model.tracks is this object where the path in the model intersects my box. This underscore underscore intersects operator here is GeoDjango's way of saying, that's a query like equal to or less than or something like that. Find everywhere where this path intersects this particular box. And then .kml says turn it into the KML format as a way of returning this data. Because we have a way in GeoDjango of rendering KML stuff very easily onto maps. This is where the framework helps you. You don't have to worry about how on earth do I now display it on the map. Let the framework help you there as a tool. All your hard work is working out the right data to display. Similarly for places, I have a box, find out everything that intersects where this location overlaps in some way with this box, be it inside or on the boundary or whatever. Works for polygons, works for points. Send it back as a KML to a, this renders it to a particular template with some parameters, fairly standard Django type stuff. And even if you're not familiar with Django there, just trust me that this is a way of saying, this is a library supplied way of turning these into data that the OpenLayers.js knows how to display on the screen. So you can cargo cult that even to a certain extent and just do what I say. So that's really it. That's back to the slides momentarily. All the code, README, a couple of versions of these slides, a long version and a short version, are at that address. If you just search for imaginary maps and my name, it will show up. I'm pretty sure no one else has given this talk ever. There is a bit of an assumption you do the GeoDjango tutorial first to get your system set up. I apologize, that's kind of where most of the pain is, but it's sort of 20 minutes of do it once, never do it again. You're set up, it works. And then, at that point, you're limited to your artistic ability, basically. There are links in the README file for this that show, where are we? Right, here. A few links to how I created those particular maps. I have the drawing talent of a brick. So if I can do it, you can probably do better. I've done dungeons like this using Inkscape, things like this. Works out fairly well. It's fairly fiddly, but it works out well. I've done islands. I've done sort of, you can even do, as you zoom in, create different views of things. So as you zoom in closer, you start to see the houses or the foliage or the tracks or the monsters and the people on the map. You can do it dynamically because you can have the locations of your raiding party or something in the database and use does it overlap with the box I'm viewing? If it does, start showing the map at some particular zoom level. So possibilities are endless here. It's lots of fun. Haven't yet managed to work out how to get paid for doing this, but really, it's lots of fun. All right, I've gone slightly over time, but maybe if there's a quick question or two.
Question.
Yeah?
What happened is WMS actually replaced the WSGI server and it renders everything from the standard content to the map layer stuff.
So the WMS bit is a WSGI server, is the WSGI compatible? Like WSGI is just an interface for web servers to talk, right? So WMS stands for WSGI map server.
So it's not you need to run two different servers?
No, I'm running two different servers because I've got the Django layer that knows how to return certain pieces of data, and I've got the map server for the OpenLayers interface. So normally you don't need to run two different web servers, they'd be two different paths on the same server. I'm just cheating by using two different development servers here.
So, so the WMS server is capable to do a render to response as well? Standard render to response.
It probably could. I haven't looked into that path. I mean, if I'm doing this where I'm going to put it on the web, I'm not going to use the WMS server or the Django development server. I'm going to use, Nginx or Apache or something like that, right, and put them under the same paths. This is just purely, I've given a self-contained code example here where I can run two web servers and it just works with no dependencies. So yeah, but it's not too much harder to set it up for Apache or Nginx or with GUnicorn or something like that. Yes?
Tweak a bounding box to avoid that, or your latitude longitude to avoid that you see an empty part of the world or you have your micro island lost somewhere. Is it possible to have a circular world?
Oh yeah. You can. Yeah, the OpenLayers sort of systems understands that when you wrap around from 180 degrees, you start wrapping around to the other part of the world.
So you can have a planet which is much smaller. You make a very.
Can you? I think I looked at this once. It was very hard to convince something like OpenLayers that I wasn't on a world that was roughly the same size as our world. Unfortunately, it assumes you're on something that is basically a sphere. It assumes it has 180 degrees of longitude, stuff like this.
You do a game with a very small map and then you...
Yeah, I mean, you probably could. I just never got into that. I haven't got into that level of hacking around on it. I should point out, by the way, my inspiration for starting to do this was many years ago. I saw a Google Tech Talk by someone who I think actually works at Google who took NASA's Mars rover pictures and basically put them as tile-based images inside Google Earth or Google Maps, and suddenly you could do like Google City Views over Mars, and then he worked out he could do other tile layers, and I thought, yeah, actually that generalizes really easily. It was at the time I thought, I mean, it sounds obvious, but it sounded like a pretty cute hack at the time to take these publicly available NASA images, and basically now you have not just Google Earth, but Google Mars, and Google Moon, and so on.
I'm sure you can do different sized planets, you just haven't found the right configuration.
Oh yeah, I'm sure I haven't too. I'm not saying it's impossible. I'm just saying I by default there are some assumptions there, and it's not amazingly well documented. The open layers documentation does not deeply go into how to do other planets. I'll give you that. All right, I guess I'm going to be around again for another hour or so, so catch up with me if you want to ask further questions or find the code and poke around. Thank you.